right, pre-cal final exam review video number 3. We left off at number 34 on the section 1 and 2 review sheet. All right, we're going to solve the quadratic inequality. I'm actually going to work this 2 different ways to remind you what to do. So we've got x squared plus x minus 20 less than 0. So you start out by just solving it like it were an equal instead of a less than. So you've got an x, we're just going to factor this, right? X, and then I believe plus 5 minus 4 would work, negative 20, that would work. But instead of getting 2 answers such as negative 5 and 4, we're getting a range of numbers that works. So our critical points are the points that would make each parenthesis 0. So it'd be negative 5 and positive 4. So what we want to do is draw a sign line. Put the lower one first, going from negative infinity to positive infinity. All right, and we're just going to plug a number in and see are we positive or negative. So let's plug a number to the left of negative 5. Let's say negative 10. We'll plug it in here. Negative 10, that's going to be a negative, and this parenthesis would also be a negative. Negative times a negative is positive. Number in between negative 5 and 4, the best one is 0. All right, so if you plug 0 in for x, it'll be positive times a negative, which is negative. And then a number greater than 4, both would be positive, so positive times a positive would be positive. So what, on this sign line, what range of numbers answers the question less than 0? Well, it's the negative range. So since it's just less than and not less than or equal, right? It's not less than or equal. It's just less than. Then the answer is going to be from negative 5 to 4. That interval, any number in between that interval, makes this true. Okay? If it were less than or equal to, then you would put brackets, negative 5 to 4. Okay? That's if it were less than or equal to. Let's do this whole problem again, saying it's greater than. Okay, you would still work it the same way. X plus 5, x minus 4. Your critical numbers would still be negative 5 and 4. And we're still going to do a sign line, but the range of numbers that answers the question would be different. Okay, so you would still get, if you plug into the left of negative 5, a plus and a minus and a plus. All that would be the same, except now you're looking for what's greater than 0. Well, it's where it's plus. All right, so this is negative infinity, positive infinity. All right, so you can't bracket infinity, so that's always a parenthesis. And since it's greater than, it would be negative infinity to negative 5. And then we have a union. And then 4 to positive infinity. If it were greater than or equal to, then we would be putting brackets here next to the negative 5 and the negative 4. All right, so just reminding you how to do an inequality like number 34, and we did it a couple different ways. All right, I'm going to erase this. Let's look at 35. 35 says solve the following. We have the square root of 15 minus 2x is equal to x. All right, let's lift the radical by squaring both sides. So if we square both sides, we lift the radical on the left, and then this is x squared. And now we can solve x squared plus 2x minus 15. If I move these over to the other side, we'll factor x, I think a plus 5 and a minus 3 will work. So our two values are x is equal to negative 5 and positive 3. The thing is, though, when you square both sides, you can introduce what we call an extraneous solution. So we have to check. Let's check negative 5. And you check by plugging back into the original equation. So 15 minus 2 times negative 5, does that equal to negative 5? All right, well, I don't think it's going to. That's the square root of 25. Does that equal negative 5? And it does not. Okay, so does not. So negative 5 doesn't check. It's extraneous. And I don't make you write it all out. You just put a big X through negative 5, and I know what it means. Let's check 3. So we have the square root of 15 minus 2 times 3. Is that equal to 3? Well, that's the square root of 9. Does that equal 3? Yes, it does. Check. All right, so that's 35. Let's try 36. So we want to solve for x. We've got 8x minus 7 to the 1/3 is equal to x to the 2/3. Now we want to get rid of these fractional exponents, and what we can do is cube both sides. So you probably wouldn't put this step on your paper, but to the 1/3, if we were to cube that, then 1/3 times 3 is just 1, so you'd have 8x minus 7, and then 2/3 times 3 would be x squared. So now we can solve it just as a quadratic. So x minus 7 minus 1. So that's a 1, sorry. So x is going to be equal to 1/7. Now, when you are raising to an odd power, you don't have to check. They both will check. You don't get an extraneous solution when raising to an odd power. All right, so we're good to go. Just give the big circle. But when you raise it to an even power, like squaring in number 35, you do have to check in order to get full credit. All right. So let's move on to the last page of this big set of review questions. Finish it up, and I'll make this video a little shorter than the others. So 37 says, a gardener wants to fence her plot in 2 equal rectangular sections. If she has 54 yards of fence and the area of the entire plot is 108 yards squared, find the possible dimensions of the garden. All right, we have 2 equal. All right, this is number 37, by the way. Rectangular sections. Let's label the horizontal components x and the vertical components y. All right, it says in the problem that we have 54 yards of fence. So add up all these x's and y's, it has to equal 54. So that's going to be 4x plus 3y is equal to 54. We also know that the area of the entire plot, not just one rectangle, but the entire plot is 108. So area is the length times the width. So that's going to be 2x times y. So 2xy is equal to 108. Now I'm going to reduce this, divide both sides by 2. We know that xy would be 54. Just makes it a little easier to work with. So y is equal to 54 over x. And I'm going to plug that in right there. So we have 4x plus 54 over x is equal to 54. All right, so, well, let's get rid of that x on bottom. That's unattractive. And there's a 3, by the way, times that. Sorry about that. Okay, so 3 times 54, 150, 162. So that'd be 4x plus 162 over x is equal to 54. And let's give that x the bye-bye on bottom. So that'd be 4x squared plus 162 is equal to 54x. All right, I'm going to rewrite that up here. 4x squared minus 54x plus 162 is equal to a bagel. All right, let's see if maybe we can factor a 2 out of this, make it a little easier. 2x squared minus 27x plus 81 is equal to bagel. I'm going to try to factor this. You should always try to factor it for at least a minute before you give up and go to quadratic formula. So 2x, x, and then I'm thinking probably it's got to be a 9 and a 9 somehow, right? Okay, so if we go minus 9, negative 9 times negative 9 would give me 81, and then 18 and 9, negative 18 plus negative 9 would give me negative 27. So x is going to be equal to 9 halves and 9. So we have 2 answers for x. So when x is 9 halves, y is equal to 54, going back to this, 54 over 9 halves. All right, so 54 over 9 halves is 12. And then when x is equal to 9, y is equal to 54 over 9, and that is 6. Okay, so what are the whole dimension? All right, we know our x and our y, but it says what's the dimension of the entire garden? That means 2x and 1y. Well, 2x, so x you'd have to do 9 halves times 2. So that's going to be 9 times, and when x was 9 halves, y is 12. So 9 by 12. And the units on this were yards. And then when x is 9, you would multiply by 2 to get the entire length there. So that's going to be 18 times. And when x is 9, y was 6. So 18 times 6. All right, so those are your 2 options, 18 by 6 and 9 by 12. Okay, so yeah, that's one of the tougher ones. The next one is also. All right, number 38. 2 scooters start at the same intersection, one traveling due south, the other traveling due west, 10 miles an hour faster than the southbound car. If after 2 hours they're this far apart, 10 root 34, how fast is each traveling? All right, we're starting at this point. We got one going west and one going south. And at the end, they are 10 times the square root of 34 miles apart. Now we know this is a distance is equal to rate times time problem. And the time is 2 hours. Okay? So the southbound scooter would just be distance is equal to, so this, again, this triangle we're putting into a distance, 2 times r. All right, remember the time is 2 and r. All right, that's the rate. Okay, so the rate of the westbound was 10 miles an hour faster, so 2 hours times r plus 10. That's how you would get the distance of this western leg of the triangle. So the southern leg, 2r, that'll give you the distance. The western leg, 2 times r plus 10. Now this is a right triangle, so we're going to use the Pythagorean theorem. I'm going to distribute that 2r plus 10, so that'd be 2r plus 20. 2 times r, 2 times 10. That's squared plus 2r all squared is equal to 10 times the square root of 34 all squared. We got to FOIL this out, all right? So that's going to be, if you write it twice, FOIL it out, 4r squared plus 80r plus 400 plus 4r squared for this one. And 10 squared is 100, root 34 squared is 34, so that'd be 3400. All right, let's consolidate. 8r squared plus 80r, and move this over here. That'd be minus 3000 equals 0. Let's factor an 8 out of everything. R squared plus 10r minus 3000 divided by 8 would be 375. And now we're going to factor. If you don't want to factor this, put it in the quadratic formula. All right, r and r. Two factors of 375 that has a distance of 10 between them would be 25 and 15. So it's got to be, since we're going to positive 10, it'd have to be plus 25 and minus 15. So r is equal to negative 25 and positive 15. You know you're not going to have a negative rate, so that's extraneous. So the southbound car, was it a car? I think it was a scooter actually, wasn't it? Southbound scooter is going 15 miles an hour because it's going R. The westbound, you just add 10. So 15 plus 10 is 25. All right, so there is a word problem involving a quadratic. So we've got a Pythagorean theorem. The previous one, we had those rectangular plots. Let's do a distance equals rate times time where we make a table. Okay, so that's number 39. All right, it says Nimrod's average speed is 2 kilometers an hour faster than Potsy. In the same length of time it takes Nimrod to drive 186 kilometers, Potsy drives 180 kilometers. What is the average speed of each? All right, so we have distance, rate, time. We got our buddy Nim and our buddy Pot. All right, it says that Nimrod is driving 186 kilometers and Potsy is 180. All right, the rate is going to be, Potsy is R and Nimrod, he's driving 2 kilometers an hour faster. So we'll go with R plus 2. And it does say that it's the same length of time, so they're both T. So distance 186 is equal to rate R plus 2 times T. 180 is equal to RT. All right, we want to know the average speed of each, so we're solving for rate. So here, let's rearrange this and make time equal 180 over R. So I've got it in terms of R, and then I can plug right there. Okay, so 186 is equal to R times 180 over R is just going to be 180. And that's going to be 2 times 180 over r would be 360 over r. All right, let's multiply both sides by r to get rid of the fraction. 186r is equal to 180r plus 360. 6r is equal to 360, and r is equal to 60 kilometers per hour. So that's going to be our friend Potsy. And then our buddy Nimrod, which I think is a Bible character, and I think he's kind of a bad guy. It's going to be r plus 2, so 62 kilometers per hour. All right, one more for this video. So pause if you need to. Number 40. I don't think Potsy is a Bible character. So we have the ball is kicked in the air. The height of the ball, h, after t seconds is given by h is equal to negative 16t squared plus 10t plus 5. How long is the ball in the air? So h is equal to negative 16t squared plus 10t plus 5. What is the height of the ball at the end of the flight? Well, it's at the ground. Height equals 0 at end of flight. So we can set 0 equal to negative 16t squared plus 10t plus 5. Now, if you were trying to figure out how long does it take to get the ball to the 5-foot mark, you would have 5 is equal to that. But we want to know at the end of the flight, how long is it in the air? Then it's 0. All right, well, you can try to factor that, but you're going to fail. So A, B, C, we've got a quadratic formula, so we've got negative 10 plus or minus the square root of 10 squared minus 4 times negative 16 times 5 all over 2 times negative 16. All right, you're going to get two answers. One of them's going to be negative. Throw that one out. The positive is 0.95 seconds. You can try that in your calculator. See if you can get it to work out. If you need to, go ahead and go ahead and consolidate all this. All right, don't just be careful. Run it through your calculator and make sure your answer makes sense, and you can always plug it back in to see if it works. That ends video number 3. We will do the section 3 review on the next video.